Getting freaky. Okay, our first contestant for the day appears to be temperature. So if you guys want to take over the podium, please do.
Am I sharing my screen, or can you share the presentation?
However you want to do it.
Can you share it? I put in the slide channel.
Which one was this?
Temperature.
Right, but is it Ethan? Is this Ethan?
Sheldon.
I'm sorry?
Sheldon.
I found the link, Professor. I could post it in the WebEx.
Okay, cool. Yeah, I'm not. I'm sure it's up there. I just, it's not giving
easy
me.
to get lost in that channel.
All right, I think we are good. I've got the timer on for 8 minutes. I'll give you a ping when we hit that. All right.
Sounds good. So we are the Temperature Project, which is an open source Spotify song recommendation web application planning to release late summer 2021 to early fall 2021. Slide. So what is Temperature exactly? The purpose of Temperature is to be a web application that is able to correlate user listening habits with the weather and be able to make playlists based off user interest and the weather in their area. Next slide. A little bit of information about Temperature. We have a goal of having users log in to train our machine learning model for making playlists. This Friday, which is 4:30. And our beta project is planned to be released around late summer to early fall 2021 with how it's going now. Our repository can be seen at this link, and we are currently under the GNU license. Contributors are anyone that can access our repository, and our project started through RCOS fall 2020. Next slide. For our project members, we have members both taking RCOS for credit and members not taking RCOS for credit. For the members taking RCOS for credit, it's me, John, Jim, Caitlin, Luke, Witten, and Kangming. And for those not taking it for credit, we have Alice and Andrew. Next slide. Our project organization. We have separate GitHub repositories for each major part of the application, which include the front end and the back end, and then separate pipelines on Heroku, which is our server. And this semester we worked on app automatic deploy, which means that every time someone commits to the GitHub, it makes a deploy app on Heroku so we can visualize their changes to make sure it works before you send it out to users. Each member in Temperature works in a specific area, so they're assigned to front end, back end, database, machine learning, and they work from there. And getting members to start, we're starting to get members to use GitHub projects tabs to assign tasks so that we can speed things up and just easily give our members the tasks they need. Next slide.
Hey, John here. So for the project organization for our stack, the front end is mainly just using React. Regarding our hosting, we started off with Heroku, but due to budgetary concerns, we are eventually planning to move over to Azure App Services. That's kind of a theme. You'll notice we've we're starting to expand to the point where Heroku isn't really meeting some of our demands. It's a little bit too expensive. For our backend, we're using Flask. That's also in Heroku. It's going to be moved on to Azure Functions. For our database, we're using Azure SQL. That is already set up, and that one's already fully on Azure. We're using Redis for a task queue, which we'll talk about later. And for machine learning, that's using a mixture of scikit-learn and TensorFlow. That's going to be hosted on using Docker on Azure Container Registry. This is we'll talk more about this on another slide.
So for our semester goals, we had a few goals. Starting the front end design, making a genre predictor to predict Spotify genre, as we don't always get the genre for Spotify songs, so we needed something like this to make our application possible. Starting to collect data from users, which happened a little later than we thought, but should be able to happen by 4:30, and finishing up the backend, being able to collect weather data for users. Next one. Perfect. What I worked on managing the team, looking into new hosting. So like John talked about, me and him scheduled meetings with Microsoft Azure and talked about what we would need if we were playing the Switch, and we were liking that, so we're probably going to switch over to that. And for coding contributions that I had over the semester, I worked on switching our storage for our app, switching it over to Redux Store, which is a kind of like an add-on for React, which is a container that can store all the data for our app. Next slide.
Hi, I'm Caitlin, and this semester I focused mainly on designing and creating the login page. So I created the actual page and the background. And I also worked on having the login page scale to different sizes of screens like iPhones and iPads. And then also early on in the semester, I worked on an issue where the nav bar would cover the page rather than resizing the page. And this introduced CSS variables to our project, which also helped some other issues. Next slide.
Hi everyone, my name is Jim. This is my second semester in RCOS, and in this project I mostly worked on the front end. So first of all, I did research and implemented an API to get a user's longitude and latitude, and then get their zip code so that we could get location data. For most of the semester, I worked on the information page, which a user sees after logging in through Spotify. And it thanks the user and gives information about who we are and what we use their data for. Part of my work consisted of aligning text, creating buttons with our logos that lead to our links, like the GitHub or RCOS website. And I had to scale the page for different screen sizes for mobile compatibility. And lastly, since it's a group project, I coordinated with Caitlin to decide what classes we were going to use in our pages and how to reuse our code well. And that's it from me. So next slide.
Hey all, Luke here. So one of the more interesting things that I was working on was working with the Last.fm API. This is a website basically for music nerds to keep track of the music that they listen to and like what kind of music it is, I guess. So it was a very helpful API for us because it meant being able to get tags related to any individual song, album, or artist that could be useful for the project. Other than that, it was stuff like updating the README. And then as far as machine learning goes, it was mainly a lot of research and learning because I haven't really worked with that in the past. As it turns out, pretty complicated. Next slide.
Hi, my name is Whitten, and this is my second semester working on temperature. This semester, I spent most of my time working with the Spotify API to create our custom temperature playlist. The image on the slide is a draft of a temperature playlist after we created, modified, and supplied it with tracks. And using the Spotify API, I wrote some functions in Python Flask to create and modify playlists in a user's Spotify account, given their permission. And these functions can include adding a custom playlist title and description to fit the temperature brand, changing the playlist cover image to add our temperature logo, and also different functions to add, remove, or reorder the tracks, like either on playlist creation or after the fact. Next slide.
Hi, I'm Kongming. For this semester, I mainly did manipulating with our database. So so I did like to connect to our database using the page admin and write a Python script to manipulate and test the database, such as providing some Python interfaces for select, insert, and delete query, and write some code about delete the outdated weather data in the database, as it is shown in the picture And the last thing is like updating the README file to provide the other teammates the access to the file. Next slide.
Yeah, so I was on full stack. So I worked with a good bit of everything for this project. So the first thing I worked on was changing up the database. So I didn't put the new database scheme up there because it was a bit large, but you can see on the link if you ever want to look at it. We had to do a lot of changes to the database to make for the data collection. And also what we had to do was working with Redis, because as we found out, like storing the user can take a bit longer than we want, because if we're storing all of their information, it can tend to take longer than when we want a user have to wait there. So we're using Redis as a task queue for a background task. So this added us something else to our stack. Also what we had to work with this was because we wanted to use Azure, because the amount of data we wanted to store, if we're going to use maybe 200 or 300 users, started to get a little bit out of Heroku's price range, because it would start scaling very terribly. So we ended up moving over to Azure. For the front end, I did some minor things, not as much as I did on the back end, but mainly working with improving some of the location API stuff, and then just transferring data from the front and the back end. If you want to see the full model, by the way, of how all their stuff looks up, that's there. I'm not going to explain all of it, but there's a zero machine learning. Some of this has not been implemented yet, but most of this has at this point. And we're just going to move it over from Heroku. Okay, next slide. Oh. Yeah, sorry. Last thing. So for the machine learning, we had to create a John classifier. We were able to create a John classifier, which is around 80% accurate. It's still not perfect. Obviously, 80% accuracy isn't amazing, but it's decent enough. The John classifier we're using is using a multilayer perception model, which is like a neural network. We had a few other options, like a random forest and stuff, but recently we told them all it was the fastest, and it was also the least in terms of data, because some of the models were gigabytes large, which we didn't want to have on our server. So that's why we chose that. Eventually we're going to use it a Docker container, and then host it on its own server, so we could use REST API to call us to use it. I think that's everything.
Let us know if you have any questions. That's our presentation.
All right, thank you. Do we have any questions? And while we're going to questions, let me start getting the next group actually staged up here, which would be Smartrider. Do you guys need me to do this, or are you ready to take over the screen?
Yeah, we're ready. I can share my screen.
Either way.
Give me a second.
All right. Any questions for Tutor? I'm sorry. Temperature. All right. Thank you. I think that was a really good presentation. Sorry, I got involved in the presentation and didn't necessarily come up with a question during it. I'm sure we will have questions coming up for you. Smartrider, are you ready to get started?
Yeah, we're ready. Can you guys see the screen?
Yep.
All right, cool. Yes, I'll just go ahead and get started. So we are Smartrider. This is our third semester as an RCOS project. We started spring 2020. We are the all-in-one RPI transportation app. I'll have the contributors sort of introduce themselves as they present their slides. So what is Smartrider? We are an app for RPI students that the goal is to allow you to easily call for a safe ride, interact with bus and shuttle schedules, see the shuttle and bus routes on a map, and then also let you know when a shuttle or bus is arriving. And our sort of main goal is to make travel around RPI safer and easier and sort of integrate all of these different public transportation systems that are available for RPI students. So our organization and tech stack, we've written our front end in Flutter, which is a framework developed by Google that allows you to create a native app for iOS, Android, and web. Our backend is in Firebase, so we have seamless database management and backend cloud functions through Google Cloud. And then we use APIs such as Google Maps and Hypertrack. So Google Maps, obviously, you get very nice mapping tools, and then Hypertrack, we use for tracking and planning safe rides. So our progress this semester, we mostly implemented safe ride calling and tracking functionality. So even though RPI has a safe ride system, unfortunately, they don't expose an API. So we met with the transportation department, and they essentially said, if you want to go through with this app, you'd have to implement it yourself. So that was the main focus this semester. We implemented calling safe ride functionality, seeing the drivers on the map, a weight estimate algorithm, and admins can track ongoing trips through a dashboard. We integrated a feature discovery for new users, so we get an extensive walkthrough of available features. We have automated backend updates to retrieve latest bus data, which ensures the app will stay up to date without manual input. And we finalized our onboarding page, which makes us look pretty professional. Then continued, we have made progress on anonymous bug reports. We have significantly more documentation this semester, and we are almost ready for some extensive beta testing over the summer semester. So next I'll have the individual members go and present their slides.
Hi, my name's Julian. I worked with both Ethan and Dean on the Safe Ride functionality of our app, and we use Google Firestore and Hypertrack for this. Some of the features that we were able to develop include location autocomplete. We incorporated user ability to call safe ride orders. We provide a weight estimate for the users, and we also plot current drivers on the map, as you can see on the example on the right side.
Hi, I'm Dean. And so with the Hypertrack API, they give a website for the admin to log in. They could see pretty much every trip, every driver, and it gives nice insights and logistics, and maybe give ways where SafeRide can optimize their service.
Hello, I'm Christopher. I worked on a feature discovery and debugging with Vincent Chen. We worked on the implementation of the showcase feature. If you look to your right, there will be a little GIF that you can see going through each showcase and feature that explains in a nice detailed description. And you can see that how it highlights important features of the app and gives the user an informative walkthrough through the whole app. Then on to Vincent.
Hi, I'm Vincent. I also worked with Chris, and we had a issue where when we try to merge into the master branch with the onboarding feature that Nathan worked on, a lot of the errors and the navigators were pretty much broken. So that's something that we spent actually quite a decent amount of time debugging and fixing. So that's something that both of us worked on.
Hey, my name's Alex, and I deal with the iOS side of Smartrider. I mostly work on front-end development. So last semester, we finally added support for Smartrider on iOS. I've been maintaining the iPhone side of the app across new versions of iOS, Flutter, and Cocoa. So like, let's say iOS 14.4 comes out. Sometimes there are many like small changes that no one really sees, but developers all have to deal with. Like, let's say location privacy issues or app transport security. Like sometimes things won't get through the network and you have to make like little changes here and there. I've kind of been managing that where a lot of the code written in Flutter also sometimes doesn't look right on iOS. You got to make little minor changes here and there. Got to make little adjustments every now and then. Cocoa, yeah, that's what I want to say Xcode uses. Xcode uses Cocoa in order to understand Flutter because you can't build the app right away from Flutter. You need the dependencies from Cocoa, or I should say Cocoa pods, their full name. I've also added support for different iPhone aspect ratios, like iPhone 12, iPhone 8, iPhone. You know, you get the idea. The notorious notch that everyone kind of hates. We kind of have to work around that, and we also have to support. We obviously have to support older versions of iPhone, like that have the giant forehead and the bezels. I also I've been working on new themes throughout the app. I kind of developed this blue and white theme for light mode. You see the light mode theme on the login screen, but there's also the dark mode theme, which is basically the inverted colors. I've kind of been implementing that throughout the majority of the app, and I think I'm done with that as of this semester. Yeah, that's.
Hi, so I'm Megan. This is my second semester in RCOS. And one of the features that I've been working on for Smartrider is this the bug feature request. So basically, like under the profile page, there is an option for the user to submit a bug or a feature request. So basically, it kind of looks kind of like what you see on the right. So the user would fill out the title and the description of the bug or the feature that they want to add, and then they can use the drop down to specify like if it's a bug or a feature that they're submitting. And then once the user submits the request, it's going to use GitHub API to create a new issue under the Smartrider repository. And yeah, that's pretty much it.
Hi everyone, my name's Alex Chen, and I've been an RCOS member for about 3 semesters now. And this semester, I've primarily worked on the backend of our app, so the Firebase part, and obviously updating our backend, with the latest CDTA data is very vital, but also very expensive. And considering how stringent Google Cloud functions are about time and space complexity. This semester, me and Ethan, our primary goal was to optimize, query speed and also memory usage, so that it can be able to run in Google Cloud. And also, we set up a system to check if the database needs to be auto updated.
Hi, I'm Hayden. This is my first semester in RCOS. I spent the majority of the semester familiarizing myself with Flutter, and I also contributed to the majority of documentation done this semester. And along with that, I created multiple unit tests to test the stability of the multiple front-end models for the app.
Yeah, so we've been using GitHub to manage versioning. We're under the GNU General Public License version 3. Last semester, we developed a build guide, which is in our GitHub wiki. We have documentation website, like Hayden mentioned, through GitHub pages. We implement a small review for pull requests to master. Bugs and feature requests are tracked in issue pages. Our GitHub automation to assign issues to different projects using the GitHub Kanban system. We have releases available in the releases page, and we do all of our communication primarily through Discord within the core team. So some of our future goals, we'd like to develop a system for sending alerts to users from Firebase, finalizing our bug report system through the app, write more unit tests. We'd like to set up continuous integration, add support for web, which Flutter just announced is stable a couple months ago. And then ideally we'd get a beta release over the summer and hopefully a production release by fall. So yeah, any questions?
Nice. Any questions in the chat? Why don't we get Simi? I think is next. Why don't we get them starting up while you while we ask you guys questions?
Yeah, sounds good.
I think my major question is you started putting in things like CI/CD or testing. Do you think did that enhance your abilities, or did that was that just more of a waste of time, or is that making things run more smoothly?
I think we're starting to see the fruits of that effort. You know, originally it wasn't as or it seemed like more of a time sink than like would produce any results. But I think now a lot of our development is going more smoothly as a result.
Cool. I mean, that's kind of what you see is there's an upfront investment where it doesn't actually help, and then you know hopefully you work your way to where it actually does. So
yeah, definitely.
Cool. Any more questions? Why don't we start typing them? If there are, please type them into the chat, and we will get answers. Sorry to be rushing everything along. Things
no worries.
Yeah, things just keep happening, and I don't want to do too many days of this because then we lose out on our other time to work. So, all right, we have Simi. Are you guys ready?
Yes, we are.
Awesome. Glad to hear it. Let us hear what you can do.
All right. All right, welcome everyone to this is Simi, our project Simulated Mind's Eye. This is a new RCOS project. This is our team, myself, Abraham Sanders.
I'm Eric Lee.
I'm Marielle Marino.
And unfortunately, Greta couldn't come tonight because of a conflicting exam. Our entire team is new to RCOS. I'm taking it for credit, and the rest of the team are currently not. And this is the GitHub repository where you can find our project. So what is Simi? So it's essentially a chatbot trained on a new type of narrative-aligned dialogue data set. So what does that mean? Traditionally, machine learning-based chatbots are trained on a data set of dialogues, conversations. So basically, the model has to learn how to produce a response for a given utterance that a user might make in the same way a person would during a conversation, such as, where are you going? I don't know. Okay, see you later. Bye. So how is Simi different? Simi uses a dialogue, a narrative-aligned dialogue data set where each dialogue is grounded in a segment that actually describes the scene behind the conversation, as you might see in a book. So for example, if we have characters Dave and Rob, Dave saw Rob leaving with his helmet on, ask, where are you going? So now the response is specific to this narrative, saying, I'm taking my Harley down to the pier. If this narrative was, if Rob had a fishing pole, maybe they would be talking about fishing. So it's all kind of in context the way you would see it in a book.
So how does Simi work? Simi uses causal language modeling, which essentially predicts the next token following a series of tokens. So in this narrative, for example, the person seems to hurt their foot. $100 bills on the floor does not make much sense given this context. So looking at the next option, pepperoni pizza pies also doesn't make much sense. As you can see, out of these three options, burning hot lava makes the most sense given the context. So burning hot lava would be added to the end. So breaking this down a little bit, causal language modeling is really working one word at a time. As you can see on the right, burning has the highest probability of coming next. So burning would be selected and added to the end. Then we see that hot has the highest probability, so hot would be selected. So next, lava and coal here both could potentially work, but lava will have the highest probability and then comes next. And then this is then followed by a period and then an end of sentence token.
So Simi uses OpenAI GPT-2 model, which was pre-trained by OpenAI on its own internet-scale web text corp, containing the text from 45 million links posted by Reddit users. And this dataset contains approximately 8 million documents for a total of 40 gigabytes of text. And the largest version have about 1.5 billion trainable parameters. So as we in the graph shows, as we input the prompt text, the model will generate many possible tokens, which could possibly be whole words, subwords, punctuation, individual characters, or the combination above. So the OpenAI GPT-2 is an implementation of the transformer neural network architecture originally described in the 2017 Neural PI paper. Attention is all you need. So we fine-tuned the GPT-2 on a dataset of dialogue plus narrative sequence of from about 47,000 public domain English language book obtained from the project Gutenberg. Like as the picture showed above, it's a sample of our dataset, which the capital N represent the narrative and the D represent the dialogue. So as the user input a narrative, it will translate into a sentence start with a narrative token. Then we prompt into a narrative token, the generator will generate a narrative response. And the same as the dialogue token, which the generator will generate a dialogue response.
So we've implemented this on top of the ML stack using PyTorch, which is a popular Python library for deep neural networks, which is similar to TensorFlow, which we saw an earlier project today was using. And the Hugging Faces Transformers library, which is a recent and extremely popular library containing implementations of many of the recent popular transformer architectures from the research. GPT-2 is available as a pre-trained model through Hugging Face Transformers, so it was really convenient for us to download it and run with it. So for our UI, we natively support interacting in a terminal, but in addition to that, we also serve the model through a very lightweight web stack. So the model is served through PyTorch and Hugging Face, and then exposed through a RESTful web API through Flask and Flask RESTful. And consumed by a minimalistic web UI, which uses Bootstrap for styling and jQuery for making the AJAX requests to the API. So we'll just do a short demo of this. So this was the web UI. So I would usually start by prefacing the conversation with some narrative segment. I'm doing this live, so you never know what we're going to get, but hopefully it will be good. So say the soldier entered the shop looking to buy a pair of boots. So that's the narrative preface. And now the conversation begins with good day. So you can see that the model immediately generated a narrative here indicating that the dialogue good day is being spoken to the shop man, I guess the person behind the counter. And the generator is now impersonating that person. I am looking to buy some boots. What do you have? So it says, I don't have any boots, but if you like to look at my stock, you can. That's too bad. How about some work shoes? Black, if you have them. Great. How much for those? 25 cents. I'll take them. Now, the generator continued with a narrative this is where the mind's eye comes into the simulated mind's eye. In the generator's mind's eye, the shopman was glad to be rid of the soldier, and when the latter went out, he said to his wife, and then the dialogue continues. That's a queer soldier. I guess he wanted to buy my boots, but he didn't get them. So that's how CME works. We also have in development some speech-to-text and text-to-speech features. So theoretically, you would be able to, and this kind of works and kind of doesn't, so we'll see how it goes. Good morning, how are you? Yeah, so you can see we can dictate in and get the text-to-speech response out, which you can't hear because of the stream setup. So you'll be able to interact with CME completely hands-free. So that's it for the demo, and I'm going to go back to the slides. So this is our progress for the semester. We have we extended an existing project called Gutenberg Dialogue, which is a project on GitHub which generates a pure dialogue dataset from Gutenberg books, and we extended it to support narrative. We use that to generate our dataset, fine-tune GPT-2, and implement our interaction interface in the terminal and in the web UI, which you saw. We also did a speaker tracking subsystem, which helps the model stay consistent with the persona it is inhabiting, and also a self-chat feature where the model can kind of talk to itself. In progress, we have documentation. I'll show you a little bit of that in a second. And then we didn't get to a couple of the more NLP research side of this to do auto evaluation metrics and response re-ranking and closed tasks, which we had in our original roadmap. So on the way we organized our project, this is a very small project, so we just had our issues or features and bugs were tracked through the issues on GitHub, and then on our main page we have documentation about how to actually run or to build the data set or download the pre-trained model and run it, and some examples of what dialogues look like from the model. And this is our server. And that's the end of it. Thank you for attending, and feel free to ask any questions.
All right. I think we're bringing up Rensselaer e-commerce dashboard next. So let's get them presenting. And while we do we have any questions for CME? Frank says checkouts as examples are pretty entertaining, which is cool. I think I like the fact that you were confident enough to place your trust in the project on people that weren't taking the course. So that speaks highly both for the community you're starting to build, and for your like I said, your willingness to put faith in it. How did you guys find it went? Were you happy working with this? Were you able to contribute?
It was more of like learning for like on my end. We were able to look at like a few of the examples, and we attended like the meetings and went through a lot of the issues that had been brought up. But overall, a lot of progress was made throughout the semester.
Cool. I kind of like that. It's good to get people who aren't. It's good to expand our the type of students who are working on the project. It's great to get people taking it for credit, but it's also good to have people just interacting with it. It does actually help to keep the project fresh. All right. Next is Rensselaer e-commerce dashboard. And again, if you have any more questions for CME, please post them. It's an interesting project. It looks like they've made a lot of progress. Let's keep them going. But Rensselaer e-commerce dashboard, please set forth.
Okay, I'll start. Hi everyone, my name is Jawen, and my project was the Rensselaer e-commerce dashboard, or in short, RED. And it's been an ongoing project for 2 semesters, and it's just me on the team this semester. Yeah, I forgot to present. All right, next slide. So what is RED? Well, namely, it is a dashboard that allows the RPEG community to buy or sell items. In other words, it functions just like the RPI for Sell Facebook group, but then in the website form, and comes with much more potential and flexible functionalities. A very common use case would be that, let's say you're graduating this semester and you want to sell the furniture in your apartment. You can then simply post those here on this website. And I think the reason why people might prefer this dashboard over that Facebook group is because I think it's a more centralized place, meaning that it's easier for people to look for what they want. Because I've seen many times when people like make several postings on Reddit, Facebook, Discord, just to get like one single thing sold, and it's quite a hassle. So I thought it would be nice to have a platform just for this. But yeah, using this website, it will allow you, the users, to log in via the RPI authentication service. And then it will allow the users to browse the latest items for sale, search for a specific keyword, filter or sort the items based on category, date, and price. You can also contact the seller via DM or the email listed. You will be able to bookmark items based on the items you're interested in, view the postings, the posting history of a seller, and all the nuts and bolts you can do in the typical e-commerce setting. And possibly in the future, one interesting functionality I might add is to enable the users to bid on items, just like how eBay does it. And lastly, as a seller, you can just simply fill a form, click on submit, and then wait for people to contact you. But yeah, in summary, the idea just to build a minimal, clean e-commerce website that supports everything except for the actual paying part, because that would be done in person, on campus or elsewhere. All right, next slide. So as for project structure, this is a blessed repository and it's MIT licensed. And let me go to the repo. And in the repo, in the repo, I have both the front end and back end code under the same repo. Yeah, which is not really good practice, and I will have to change that in the future. And I also used README to document requirement, installations, and other information. And I used the GitHub wiki to keep track of the current progress, and the issue tracker to keep track of the current bugs and future enhancement. And so far, I've had about 97 commits. For 2 semesters. Okay. All right. Next slide. So for the tech stack, I used React for the front end and design for the UI of the UI library, and Babel plus Webpack for the build tool. And then for the back end, I used Express.js, PostgreSQL, and I use Motor and SQLize for file transferring. And then the front end and back end are connected by REST APIs. So yeah, it's a really straightforward stack, nothing too tricky, and it's mostly web development oriented, I would say. Okay, and this is initial wireframe I came up with last semester, and I'm not going to go too deep into that, and I'll just go straight to the demo. So yeah, I already have the application running on localhost here, and I've already inserted some data sets this morning. So yeah, as you can see, I have like about 12 items in here. Actually, more than 12, yeah, 3 pages. And all the items here are displayed as cards, showing you the name, description, date they posted, category, and price. And you can also use the sidebar here to filter based on category. So per se, you want to do like school supplies, furnitures, electronic devices, clothing, and blah, blah, blah. And you can also sort by date range. So everything's created this morning, so it'll fall into the categories of all these 4. And also by price range. So below 50, 50 to 100, 100 to 200 and above 200. And yeah, let's say that you are looking for a new desk, and you can just simply search in the search bar here and just type in desk, click on here, and there you go. And if you're a seller, you can then just fill out, you can just like click on this button here and then fill out a form. So let's say that I want to sell my dresser that I'm not going to use anymore. So I'm just going to type in dresser and then select the category, give it a price, blah, 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 and then upload a picture here and then insert. And then once you refresh the page, it's gonna be at the end right here. So yeah, in the future, there's a lot of UI enhancements to be made for sure. One thing that I'm thinking is to indicate whether an item has been sold. So there might be like the word sold in bold red on top of the card here, if that dresser is sold. And there will also be a place in the card that shows the seller's preferred way of contact. And I want to allow like each item to display more than one image. So let's say that you can click on an arrow here that's not existing right now, and just gonna like bring you to the next image. It's nothing too tricky, I'll say, and there's a lot I can improve for sure. All right. And let me go back. All right, so as for progress, last semester, we had the basic code infrastructure set up, and we had some basic UI displayed and some trivial backend implementation. And this semester is just me, so I worked on the full stack, and I kind of re-implemented the entire UI, so it looks completely different from how it looked last semester's. And I've also implemented the filtering functionality and the upload image functionality using SQLite and Motor. And I've also enhanced the database model to make it adhere to more real-life situation. And there was also some code refactoring and documentation as well. And lastly, for the future plan, aside from the UI enhancements I mentioned earlier in the demo, I'm also looking into improving the searching algorithm fairly soon, and improving the filtering and sorting functionality on the UI, and user authentication via the RPI ARC service, and of course the DM and the bidding system that might be really interesting, and also the containerization and deployment. Yeah, and there's a lot more that can be done. It's just but yeah, I'm graduating this semester, so I probably wouldn't have time to like spend on this after I leave. But if anyone is like interested in taking over, feel free to like email me after class. And yeah, that's so. Any questions?
So there's a question in the chat from Alice asking if you're going to deploy soon.
Unfortunately, this is still like under construction, so like it might still take a semester or two until like the actual deployment, I think.
All right, I do like to recommend you guys go for minimum viable product early. Talk to Jason Krusevich down in the Severino Center about the benefits of going before, after you have something reasonable, but before it's completely done. I think we make a lot of mistakes sometimes as engineers about waiting for perfection rather than getting missing the deployment time. Cool, nicely done. Go ahead. Please feel free to comment. I didn't mean to cut you off.
If I could throw something in on top of that, it's kind of off the cuff, but yeah, that looks really polished. It would stink if, it's just getting off right as you're graduating. So we as RCOS, I think we could do a little bit more to maybe help help the passing down of projects. So I will reach out to you at some point after this, and maybe we can see if we can get people in RCOS to keep it alive and pass that down, since that'd be great.
That'll be great. Thank you.
Awesome. I think the next one, I just broke a piece of glass. You shouldn't fiddle with stuff while you're watching presentations. But let's go on with Raid TA, please.
Hello. Can you hear me?
Yes.
Yes. Okay. I can share my screen if that's okay.
That would be perfect.
All right. Okay. So let me do this. Make sure that's okay. Yep. All right. Sweet. Hi, everybody. My name is Brian Mejia. I am the RCOS representative for Raid TA. I have another teammate, but they're not going through RCOS, so I'll be presenting for the both of us. So Raid TA is a simulator for MMORPGs, stuff like World of Warcraft and Final Fantasy XIV. It mostly covers the meat and potatoes of the game, which are raids and dungeons, which are encounters in which you and up to, I want to say 15 other people, usually 3. So like groups of 4, 8, 16 go up against some kind of boss. You know, it's varied and it's also very difficult. This was designed to be a practice tool for players of this game, because it's pretty hard to get your friends together consistently to practice these kinds of encounters. You have to at least get 3 other people to get something going. And while there are videos detailing how to get around these encounters, nothing's better than getting a practice round in. So what this program intends to do is to create a modular experience for people to practice, encounters that they see in these games and make their own in case they want to practice a certain mechanic or whatnot. So this is a second semester project. Last semester was our first. So we have some legacy features, such as single player party control, in which a player can take control of up to 6 units, and these units are split into roles. We have the damage role; they do damage. The tank role, they go up front and take all the damage for all the party members, and the heal roles, who heal. And another thing we had was party NPCs. If a player isn't selecting a unit, then they do simple actions such as continue targeting an enemy or heal other players. And we also added boss mechanics. So stuff like area of effect attacks and screen-wide damage, just to give players the sense of movement and the ability to work around these attacks. The tech stack is very small. It's kind of a game dev project, so we just have Unity. We switched over from Unreal compared to last semester because it was getting increasingly difficult to implement the features that we wanted. And we felt that since our lead had more experience with Unity, that it would be easier to put these features out through the Unity engine. We worked through this on Git using a blessed repository. We have the main repository and then 2 sub repositories for each of our team members, me and Austin. And we do pull requests for the main branch. One thing we did have is we wanted to keep track of feedback, so we used the issue tracker to keep track of things that we needed to implement in the future. And with Discord, we just use Discord to meet up and plan what we wanted to do for future weeks and how to execute them. So with new features, essentially, to make a long story short, we got feedback from some game developers and about what we should be working on. So we shifted development work from mechanics to UI and customization, like quality of life stuff that gives player agency to the application. So we did UI changes. We gave each of the roles their own distinctive colors, as you see in the picture there. The red is the damage, blue is the tank, because they're up front, and then green in the back for the healing. And we added target lines, sight lines for each of these units, so you could see what each unit is targeting. And we added unit numbering. Since right now, the way to select a unit to control is to use a number on your keyboard. So we wanted to show which unit belongs to what number. We added a threat system. Usually these games have some sort of priority queue that determines which player and enemy is going to attack. And to keep things basic, the tanks are usually prioritized because they have a higher threat modifier than the other units. So this gives a way to simulate these encounters better. Recently we added party creation. So before an encounter, you can create a formation of up to 6 units of each of these 3 roles. And if you want as well, you can edit the statistics of these units based on how much health, damage, speed, and other stats for that. And lastly, we added party saving. Basically, you can put in a string to save this formation, and then you can put in the same string to load that same formation. In progress, we have visual coding. I'm not working on this, but from my notes, it's basically a state machine that generates code for generating encounters for players. Stuff like the general execution or program flow stuff like if, and, or, and not. Execution nodes, whether you want to spawn like an NPC or an attack or damage a certain enemy. And then access nodes for information, such as getting the statistics of a unit or getting some sort of raid information. And then we also wanted to implement logs, keeping track of damage events or unit deaths, and a way to timestamp these events. That way you can go back to a certain point in time of the encounter to see if you could do that part any better. All right, so if I go here, and the UI is very basic. We're not UI designers, but we want to keep things simple and make sure it works. So if. All right, so this is our pre-encounter menu. You can have your formation set up by clicking a role and then just clicking and they will show up. So I could save this as a sort of formation with the string and then that'll save. But this isn't really the ideal formation. So let's say I want to get rid of some of these units. I can just delete them over here and then add a more typical formation that will give more of a chance of success. So add a healer and then maybe like 2 damage units. And let's say I want the damage units to do a little bit more damage. I go over here, add a number like 25 here, 25 here, and save that as party 2. And we can load these formations. Sorry, you have to remember the strings right now. I wanted to add a drop down, but I didn't have enough time for that yet. But you could load the formations, boom, boom, done. And you could start the raid, and there you go. So it'll target the tank, the healer can heal the tank, and the damage units can go after the NPC. And that's really most of it. Yeah. Here. So when it came to organization, it was a bit more chaotic compared to last semester. We kind of just took whatever we felt like we wanted to do. But breaking it down, me and Austin worked on UI changes. Austin worked on the target lines and the unit numbering. I worked on the UI clarity. Like say, for example, the fonts were a little blurry and we didn't really get to see like what unit you were selecting beforehand. So I added that white little highlight that shows which unit you're using, and also added health bars to each unit. Austin worked on the threat system and editing the unit statistics. And I worked on the party creation, the drag and drop system, and the save and load system for the party members. Right. And now for our future prospects, we have a few things in mind. One of the things was we wanted to add more sophisticated actions for the AI members. So that way, if a player wanted to focus on a certain role, they could. We want to implement specific encounters, but these would be a model for player-generated encounters. That way, a player can know what they can work with. And once we're done with that feature, we can add documentation, so it's easier to use. We wanted to add new mechanics. That was our original development idea, but that got pushed back because of the feedback. We want to add things like debuffs, damage over time effects, and forced movement, so that way we can further model these encounters a little better. And overall, these features will give into our overall vision in which we want people to practice. And with the creation tools we have right now, I think that helps a lot, but we can always add more. Yeah. That's all of it. Does anybody have any questions? Oh wait, I see one in the chat. Sorry, this like screen sharing UI is a bit strange. Nope.
While you're answering that, let's get Clarion up or get them started.
What was used for NPC AI scripting? It was I believe we used state transitions for that kind of thing. I was not the main guy to use that. Video is on. Sorry. I was not the main guy to use that, but we had state transitions from like idle to attacking to depending on role actions like healing or mitigating damage. It's very basic, but we hope to expand it over time.
All right, nicely done. Your bad guys have the ability to do damage too, correct?
Yeah, yes, they do. Yeah, I was going quickly over it, but we
Yeah,
do
no,
have the AOE attacks, and then the screen wide damage. And the demo might have gone really quickly, but the enemies have a red target line to show who they're attacking.
That's what I thought I remembered. So I just wanted to bring out that this isn't a safe raid. It's not.
Yeah, absolutely not.
You're getting damaged. Cool. Nicely done. I like the fact that I like the fact that we have a lot of projects that are stretching across former and current students, and it's good to see these communities working. I guess is what I want to say. Did you find it was useful working with your friends, even though they weren't necessarily doing it for credit?
I did personally. It was mostly the same workload. He just didn't want to put RCOS on his course load, so the workload was the same, really. Same method of communication, same method of working on GitHub. So not much has changed, really.
Cool. All right, Pi Clarion, are you guys ready? I'm seeing you up in the thing now. We're not hearing anything yet, though.
We're ready. I couldn't unmute myself. Anyway, can you guys hear me?
Yeah, you're good now.
Okay. Hi. We are PyClarion. PyClarion is a Python library for the Clarion cognitive architecture. John will explain more later. Our team is led by John and Makik, and our team members are Joe, Zhang, and me, and Jenny.
Okay, hi everyone. Hope you can hear me. My name is John McKeek. I'm a CogSci PhD student and maintainer of PyClarion. I'm just going to give you a brief overview before leaving it to our contributors. So what is Clarion? It's a cognitive architecture that incorporates both neural networks and symbolic representations. It's kind of like a simulated brain, but much more abstract. And you can think of it as a network of neural networks with some extra bells and whistles. So PyClarion is a rendition of Clarion in pure Python for learning and for experimentation. Our goal for this semester was to work on a new release focusing on quality control. And contributing to PyClarion is pretty simple. It's mainly through the GitHub. The README has some general info. Contributing file provides some procedural information, but the process is very simple. Talk to a maintainer, so somebody like me, via GitHub, ideally, fork code and submit a PR. Before leaving it, I would like to thank the contributors. We had a great semester, I think, and I was inspired by their commitment and enthusiasm.
Hi everyone. I'm Zane working on usability. As Jenny just mentioned, PyClarion is a project working on the Python. And probably all of us know one important difference between Python and many other great languages is that Python doesn't have type declaration. And while it is often convenient to do so, many other times it's causing difficulty debugging and also decreased stability. And that's the reason why I added type annotation to all of the major components of PyClarion. Basically, it specifies the argument type and the return type of Python functions, and will complain about it when the typing doesn't match. On the other hand, I also worked on a new demo to show a very simple functionality of PyClarion. What this demo will do is that it will simulate certain human behavior step by step using a fixed rule database. More specifically, the agent will be hungry or thirsty at first, and then set up goals to travel to store and buy corresponding items to satisfy the needs. And on the right, it is an example of how we define rules in a fixed rule database, and also one step of the simulation in the output. As you can see, for each step of simulation, we update agent state, external actions, goal actions, and current goal stack, and more. And those information will be fed back to the agents to do the next step. So overall, when I first took this demo,
it was rough and a bit unorganized, but now it is a very clean and sophisticated demo. So yeah, that's basically what I did for this semester.
Hi, I'm Jay Chu. I worked on Numdix and unit testing Numdix this semester. Numdix are numerical dictionaries that allow for automatic differentiation, which is helpful in training neural networks. This allows the user to perform a sequence of operations within a gradient tape, which records the operations performed and differentiates a given provided numdict with respect to the requested variable as specified in the gradient function. The example shown tape is the gradient tape used to record the operations. Result is the numdict used to store the operations being performed, and the 0th index of grads is a numdict representing the derivative of result with respect to the variable x. Unit testing numdix involves verifying that numdix behaves as expected, verifying that equations like the one provided return the correct results with real inputs. Since numdix are dictionaries and have keyed values and default values to be used in view of keyed values, tests have to verify that the tests work given only default values, only key values, and when there are numdict operations with mixed values and keys. In the course of unit testing, I wrote many tests for a variety of operations, which can be seen. Additionally, this semester I worked on implementing and testing nested differentiation of numdix. Nesting numdix ideally will allow the user to calculate any and all second derivatives of a function without much additional code. In the example above, the 0th and 1st index of G1 represents the first derivative of result with respect to x and y respectively. Since the indices of G1 are numdix, the following syntax will obtain the second derivatives of the result. Unfortunately, the implementation of this feature has not been so straightforward, and there have been some problems and bugs at the moment.
Hi, I'm Jenny, and the main component I worked on this semester was RER.py. RER is the rule learning algorithm for Clarion. So while on the way of working on it, I did some background work, which is basically in chunk and in rule class. I wrote the match function that checks for matching for features, weights, and rules. So RER is not finished yet because it's kind of difficult to go from a described algorithm to actually implementing it. The algorithm is described in Anatomy of Mind by our own Professor Ronson, if anyone wants to read there. But definitely RER is getting there. I also helped fix bugs in BLA. BLA is the general that we use in Clarion to model memory decay. And I helped fix in the classes where the stat does not line up when updating. It does not line up in the containers when updating. So that's what I did this semester. And thank you, and please ask your questions.
Nicely done and very efficient. I seem not to be asking many questions, but I do seem to be giving a lot of comments. I got to say that I love that you guys are concentrating on testing. So that's the kind of thing that can separate a awesome project from a so-so project. Is just the ability to have the confidence that when you're using it, it's actually working correctly. So I will leave that comment as it is, and I will let you go to the comment in the question in the actual chat. Are Numdix autodiff implemented from scratch, or do they use something like TensorFlow gradient tape under the hood? And if not, why do you guys opt to implement this from scratch when many libraries have done autodiff? And by the way, IBM Truth Loop, do you want to get started up while they're answering the question?
So I can answer that question. They are implemented from pure Python. So we sort of use the Python dunder methods to get addition, subtraction, all that stuff. Why not use something like TensorFlow? Well, in the past, I was using Theano, then Theano sort of died. And I thought it would be easier to learn something complicated like cognitive architecture if everything was sort of in one place and implemented as simply as possible. So not going for efficiency, but for intelligibility.
Cool.
Also, it was fun.
And there's the big important thing. If you're not doing something fun, then it's much harder. Nice job. All right. Thank you. And if there's any more questions, please put them in the chat so we can get some truth. Very nicely done. Great presentation of the presentation. Good job. Esther?
All right.
Okay.
So I'm Omar, and I was part of the Call for Code Truth Loop project. And we're going to get into what it is, but it's a project sponsored by IBM targeted for racial justice. So next slide. All right, so what is the problem that Truth Loop tries to solve, right? So the problem is that concerned and impacted citizens don't have an easy way, straightforward way of understanding new legislation that comes out and how it affects them. So the solution, or a solution to that problem, is TruthLoop. And TruthLoop is a mobile app that simplifies legislative artifacts. So that includes any sort of new piece of legislation. And it summarizes the key points of the legislation so that it's easy to understand and you don't have to parse a lot of legal jargon to understand it. And additionally, it gives members of the Black community, because that's the group that they specifically targeted, and allies of the Black community, the opportunity to share and upload video clips on how the legislative artifact that was just added, that was just summarized, how it affects them. And so you get this system of you understand legislative artifacts that are coming out and how they affect you, and people react to it, and you understand how it's going to affect them on a personal level. Next slide. All right, and now going into the tech stack, right? So we use a variety of things when working on TruthLoop this semester. So of course, since it's a web project, we use HTML and CSS for styling and structure. We use JavaScript for interaction. And the main thing that we used was Vue for our web front-end web framework. I think all of our team was new to Vue, so it was a good learning experience for us. Then they used Node.js for the backend. So they set up Express routes and an Express server to interact with. And then they also had a database, and the database stored legislative artifacts and information related to legislation. And so they would use Postgres SQL on the for the database. And they also write like doc strings. Like if you've ever seen Java doc style strings, every method would have that like specification. And so they used a tool called Swagger Docs that we had to like use when we wrote like new functions. And then lastly, we use Supertest and Jest for our testing framework. And I say they/we because this is an actual like IBM sponsored project. So it's not completely just us. It's like both of us. All right, next slide. All right, so meeting the team. So yeah, my name is Omar Kobas, my second semester of RCOS, and yeah.
My name is Kelly Fellenzer, and this is actually my first semester of RCOS.
My name is Ryan Carrito, and this is also my first semester of RCOS.
And I'm Escher, and this is my second semester of RCOS.
So for our goals for the spring 2021 semester, goal 1 was the repository organization and maintenance. We wanted to set up and basic README cleanup and have a basic README cleanup, finding and fixing bugs, understanding the code base and its technologies. Our second goal was to address GitHub issues, fix about 6 of them, or as well as raise some new issues that we would find along the way during goal 1. Goal 3 was to possibly propose a new feature for this application, and goal 4 was present our work at an IBM forum or community outreach event and to RCOS. And next slide. And as for our achievements for these goals, we were able to, for goal 1, we were able to set up our computers with and fix up some of the README incorrections that we found along the way. We fixed a couple of bugs with TruthLoop, which we'll discuss more later. And within the time, we are also able to understand a lot of things, new things, reading through the code and learning the code base with help from IBM mentors, which we'll have discussed more later. For our second achievement, we were able to work on about 6 to 7 different issues, with 4 issues being closed, and with a total of 14 pull requests combined, which were accepted and merged to the master. As for goal 3, we did not get to propose a new feature, but instead we were able to focus on the current issues. And for our last achievement, we are all presenting this presentation again to the IBM team on May 4th, and currently now. Next slide.
All right, so now we're gonna dive into like contributions that we made. So basically there was pairs of 2, and like Ryan and I worked on like a certain set of issues, and then Kelly and Escher worked on like a little bit different. And so on our side, right, the first thing we worked on was in terms of pull requests was README enhancements. So we did that just to get more accustomed to the project. So we did some like, we added more documentation on like how to, there was a correction with like a button that was in the wrong place or something. So we would add something for that and different typos and things just to get started. And while we needed time to get used to the code base.
For our second, integration testing for Node.js and routes. These were basically tests for if the application and database were able to interact properly and accordingly and how they're supposed to within application functions.
Yeah, and then the last thing we did, like the last section of things we did, was we worked on bug fixes. So we worked on things related to Vue.js, and it was when we started learning a bit more about Vue and fixing things that were problematic. For example, there was a bug that, so of course you're allowed to record yourself and upload a video snippet of you talking about legislation, but there's a bug that while you're recording, the screen is black. So we worked on that bug. It's the top one. And then the ones in the middle, like it says test, right? We added testing for the backend routes, the express routes. And then the things on the bottom of that GitHub image, those were the README fixes that we did. Yeah. Next slide.
So for Escher and I's contributions, we focused on one of the main issues with TruthLoop regarding its accessibility to the public. So when implementing TruthLoop on your local device, you have to not only like download all of the required tools, but not like you have to sign up for specific subscriptions to these to access the app. And so this is very expensive and it's definitely not accessible to everyone. I would be remiss to say it's probably not accessible to even people who could afford it. And so what we focused on was switching TruthLoop's content management system and relational database management system, CMS or RDMS, to cheaper and explicitly free options as well. And so what we decided with our IBM mentors as well is to focus on Concrete 5 as the new CMS, which utilizes MySQL, and they are both free. Now, in the graph, you can see that we also, by using Concrete 5, you have availability to use other RDMS database management systems, but we were not focused on that for this semester. Next slide. So we met with our IBM mentors twice. To the right, you can see 4 different people who work at IBM currently and are located across the world. For our first meeting, we met with these people to discuss the different CMS replacements and important areas in TruthLoop where we could give our most contributions and efforts. And then on March 25th, Omar and Ryan can discuss what they covered in their meeting with IBM.
Yeah, so in that second meeting, we met because we wanted to tackle issues related to user authentication, and we needed more clarification on how it works or what they wanted. So we had like an hour and a half meeting where they explained to us like how TruthLoop like works more in depth in terms of the backend side of things. And so it was a great experience hearing from them like how they structure the project and how it works. Yeah.
So during this project, we also contributed to the Call for Code hackathon, and our project name was COVID Vaccine Tracker. And the purpose of the Call for Code hackathon is to build and contribute to sustainable open source technology projects that addresses social and humanitarian issues. So we spent 1 week on this project, and the project that we had at the end of it basically was a map of the world, and each country was a different color based on how many vaccinations they've given out. And so our next steps are to continue to switch TruthLoop to a free content management system and a free relational database management system and cloud integrated platform. And then a goal for the future would to begin testing and evaluating these new platforms. Some other goals are user authentication for TruthLoop and video testimony issues and bugs, which are all in the GitHub. And this was the first semester for TruthLoop that they had RCOS involved with. So we hope that our work sets it up for other people to contribute even more, and TruthLoop has a lot of contributors in the future. And during this project, we all learned how to interact with an open source team, and we all learned how to make contributions on a well-developed code base. We learned aspects of CMS, RDMS, and cloud platforms and how to use them. We also learned what it takes to develop a open source project and how you can maintain it. And some of us also learned about backend testing and Vue.js development. And that's the end of our presentation. Thanks. And does anyone have questions?
Very nice. Let's get BrokerBot started up. I think we may run a little over today, guys, just to get everybody prepared. So while you're doing that, was the project set up to allow you to migrate? Had that been taken into account? Because it's really not a bad idea to just get something up and working to get you to a minimum viable product, and then as you find issues to move on from there. Is that kind of what was done? So you were working in known ground when you were migrating away from these other tools?
I know that they had, go Go
You
ahead.
can go, Asher.
Sorry. Okay, I'll say. So they had already started thinking about switching over to another platform. I'm pretty sure that was the case, but they hadn't really done any work on it. And currently what we have now is just a lot of documentation on how they can start setting up the new Concrete 5 system.
Good. I mean,
yeah, we tried implementing our own versions on our local devices, and we came up with a lot of difficulties. And regarding like their choice of the CMS, it turned out not to be free at some point. Like at some point in use, when you get to a certain usage limit, you had to pay for a subscription. So we were going to bring that up in our next presentation with them.
yeah. But that's a mark of success if you're getting up to the point where, just, in some measures.
Yes.
Right? So cool. Nicely done.
Thank you.
Any more questions in chat? Do we have BrokerBot coming up? Neither one. Okay, we have a message out to Jack. Are you pulling the slides up?
I thought that should I just start sharing my own video then?
Whatever you guys want to do. Do you want me to bring it up or
I could share. That'd be honestly probably easier.
Okay. We just need instructions.
Yeah, here. Let me start sharing my screen.
Cool. I think I've seen this.
Yeah. All right. So this is BrokerBot. I'm the project manager alongside my teammates Will Carter, Will Zielinski, Andy Pham, and Tommy. So BrokerBot is a algorithmic trading bot capable of continuously analyzing market conditions to make profitable trades by automating trading strategies such as momentum and mean reversion. This semester was a lot of foundational work and a lot of structural work. Some of our accomplishments include constructing architecture capable of executing strategies across multiple exchanges and in parallel. So what we really focused on was trying to set up an architecture that would allow us to trade any type of security, whether it's a stock, crypto, Forex, or whatever, through one main application, and being able to run all of those in parallel at the same time. And we also created a framework to back trade strategies and crafted as simple as trading strategies to test our functionality. One second. There we go.
Hey all, I'm Will. And if you take a look at our repo, you can see that we've had a fair few commits over the past 3 months, and we've made a lot of progress towards our goals. In terms of like progress that we sort of thought of as being distinctive, implementing all of our classes for our current desired structure, which we'll show you guys in a bit. That was pretty important to us. Giving all of our classes and functions a uniform specification format was very helpful from like a documentation perspective. And of course, our semi-distributed architecture, which allows for like parallelization of trading processes, which is very helpful for efficiency.
The core of our architecture are handlers. We have several, and this was a pretty good way to divvy up different work. Will Carter worked on our data handler. I worked on the strategy handler. Will Zielinski worked on strategy. Bob worked on our scanner/searcher, and Andy worked on our execution handler and our portfolio manager. The general structure of our bot begins with a main control. This is what would be running on like on a Heroku server or an AWS server, and this basically will manage different instances of BrokerBot. Each user will be given one instance of BrokerBot on which they can have multiple different strategies running, and one portfolio manager that can overview all the assets of that user across the different exchanges. So BrokerBot can have several different strategies grouped up by different combinations of APIs that you want to use. So, for example, a crypto API might be different from a stock API, but we want functionality for both. So you might make a strategy handler for the crypto one, strategy handler for the stock one. Now, each of these strategy handlers can actually have multiple strategies. For example, if a user wants to increase throughput of a certain strategy that, say, works really well, they can make multiple instances of it and have it all run in parallel. All of those going to a single execution handler, and all of those being facilitated by a single screener that will feed good stock picks to these strategies that can then look farther back into the past and do a more technical analysis on them through use of the data handler, which is our connection to our API.
So we've mentioned this semi-distributed architecture a few times, and in our original planning for the application, we thought we have a lot of different things. We want to have them all be running at the same time, and we want it to scale well. And that sounded a lot like a distributed architecture. But in our case, we're actually running one main Python script that leverages a few powerful Python libraries. This is the threading and the multiprocessing library. A quick overview of both is threading uses traditional threads, for instance, from the operating system to create a threaded function. And multiprocessing creates a new process similar to a thread, but in its own memory space, utilizing different cores of the CPU. So how we use it specifically in our application is that main control for each account user will create a BrokerBot process in its own memory space. The BrokerBot then can create multiple strategy handler processes for a given category of strategy that a user wants to run. And then each of those strategy handler processes spin up specific strategies running an actual algorithm for a given stock that's fed to it through a searcher process. And finally, each of these strategy handler or strategy processes utilizes a threaded data handler such that it can stream data on an initial stock, and then that same class instance can be called to update some streaming channels interfacing with the Alpaca API. To make all of this work and to connect all the pieces that are running on different processes and threads, we have some key data structures that we used. So for inter-process communication, we utilized a pipe mechanism that is part of the multiprocessing library. This is basically like a pipe for the OS where there's two connection endpoints and data is fed from one process to another in the case of a searcher and a strategy. And we also utilized some thread-safe queues to share data across threads. An example of this would be the data handler receiving a stream of data from an API and then feeding it through a queue to a strategy on a different thread.
So for the data handler itself, its main purpose is essentially to connect to whatever trading API you're looking for. It requests that data type and how frequently they want it from the external database, and then it dynamically parses that JSON data into our internal format, which is sort of like the lifeblood of our whole system for use in strategies, screeners, execution handlers, back traders, etc.
Main job is to kind of facilitate what a lot of different strategies that may fall into one specific category. So what this does is it will be like one instance of the strategy handler per category, and then this could have several processes under it. So for example, if I have one strategy that I really like and works really, really well, I might want to increase throughput on this strategy and basically run like 4 of them in parallel on one exchange. And the reason we kind of group them up like this is because we figured that it'd be much better to have one screener facilitating all these different strategies and one execution handler for all these different strategies. That way we don't need to run so much code in parallel and one for each. So we combine them each into these different categories, and they kind of run these different run and facilitate these different pipe connections and monitor the status and clean up these processes when the market closes.
So we decided to come up with a simple strategy for testing. So the strategy is the bearish bullish engulfment candlestick pattern. So the candlesticks are just another type of graph used in trading analysis, and the candles represent a certain time frame. So a bullish trend is determined if the current candle's closing price is greater than the opening price, and the previous candle's closing price is less than the opening price. And also the current candle's opening and closing prices are greater than the previous candle's opening and closing prices. Thus, this makes the current bullish candle engulf the previous bearish candle, and vice versa for the bearish engulfment. And in terms of technicality, the strategy takes the stock with the highest priority from the screener's priority queue, and if the bullish condition is met, it uses the execution handler's create order function to make a buy order in the market and a sell order if the bearish condition is met. Next slide. So in trading bots, screeners are generally used to quickly analyze stocks in the market and pick the noteworthy ones to trade. So for BrokerBot screener, we have a screener prioritizing on existing set of stocks. Currently, during the initial testing phase, we are only using a small set of stocks, but we plan to go up to the S&P 500 later on. So the screener uses pipes to connect with the strategy handler and the data handler classes, and stock picks are stored in the priority queue. So the priority is determined by the average change in volume of a stock. So we use this computation because it's safer to trade in more liquid stocks, plus an increase in volume usually means more activity to come, such as a bullish trend or a bearish trend. And finally, the screener gets its data from the data handler and uses helper functions to compute the average change in volume for each stock in the queue. And finally, it sends this updated priority queue to the strategy handler. Next.
Andy, you there? All right. Well, Andy, one second. Our other team member, Andy Pham, worked on the execution handler and the portfolio manager. The execution handler, its main job is to actually execute the trades through the Alpaca API and handle all of our money allocation. This is so that once it receives a trade signal from the strategy handler, it can properly allocate as much money necessary to this stock from our total portfolio value. And this also ensures that no margin is being used. Margin is basically when you borrow money from a brokerage and you can borrow up to 4 times your initial investment. However, it's also very risky because if you cannot fully liquidate at the end of the day, you will end up being in a lot of debt. So this ensures that we don't have any holds on our accounts when we trade, that we allocate the proper money, that our trades actually go through, and that no margin is being used. He also worked on a portfolio manager. Portfolio manager keeps track of the account's portfolio information and total portfolio value across all the different exchanges. So whether we have some stocks trading through the Alpaca API on stocks or through a Binance API on cryptocurrencies, this will basically manage across all these different exchanges what their total liquidation is, their total value, their profit loss, and how each strategy is doing. This also is where we do our basic I/O for the user, where they can select which APIs they want to use and kind of mix and match and interchange them depending on what API keys they've actually paid for. Because in the world of fintech, not all APIs are made the same. So you might have one data API that only will give data, but you might need to use a different one for actually executing the trades. So this way we allow for mixing and swapping between users and a lot of customization in that. They can also select and switch strategies and output current positions and do performance analysis on strategies.
So one of the main issues with our primary API, Alpacas, was that it limited every user to one socket, WebSocket connection per account. So we decided to leverage a third-party API that utilized the Python async event loop, as well as threads to field multiple algos at once in the form of various different WebSockets who all utilize the same credentials.
So in terms of documentation and organization within the project, we have a short README file for the project description and the visual aid, which you saw earlier for our structure. But most of the information for outside devs is contained inside our functions and classes themselves. We have a very comprehensive specification system for everything. We also used Trello internally on our team for management and completion of various tasks with a basic agile methodology.
The main source of issues along this semester of development were managing lots of different threads and processes and debugging throughout that, as well as third-party libraries like the WebSocket, as well as iterative development sometimes led to merge conflicts when we were all working on different classes and trying to integrate everything.
Include integrating a Cerebro backtrader so that we can trade we can backtrade no matter the exchange, no matter the API, as well as implementing further APIs that we can execute on, such as Binance for crypto, converting to a web app framework and adding a web app UI for this, and begin paper trading and testing different strategies and kind of dipping our toes in the water of the trading marketplace. That's all. Any questions?
All right. I think we're going to have to cut the questions short for right now. If you guys have any questions, please type it into the chat. We are 5 minutes over our allotted time, and we still have S90X to go. So I just want to ask S90X Linux 1, do you guys want to go today, or we could move you possibly to Friday? It's up to you. I'm happy to stay here. In fact, it would be fine. But I just want to make sure that you guys are okay sticking it out, as opposed to we can let you run on Friday instead. All right. Why don't you guys get yourselves set up? If there's any questions for BrokerBot, we will let them go, and or we will put them into chat, and let's get through our. This is one that I'm excited about, by the way, because they're porting, if I'm not mistaken, they're porting existing open source projects into a new architecture, which is fraught with danger. That's where there be monsters on the old maps used to. It was just for this. Eat danger for breakfast.
Can you hear me?
Awesome. Yes, we can hear you. You're coming through clear.
Can you hear me?
You as well.
Amazing. All right. So yeah, we are the IBM S390X project. As Turner just said, our team is made up of Xiaoyu Yang and me, Alice Vivo. We work very closely with our IBM advisors, especially Cindy Lee, with whom we met every week. We consulted with Javier Perez about what projects we should port, and Susan Malika seems to be some kind of leadership position with the IBM RCOS projects. Next slide.
So our goal for this project is port the open source application to S390X for the use of IBM Z mainframes. So what we're doing this semester is porting OED, which is a project from RCOS. And since me and Alice are both new to Linux, for me it's my first semester in RCOS. So most of the time we are learning. Linux, such as the architecture size and the application compatibility, and the Docker, especially Docker and Docker Compose. We spend quite a lot of time on it. And for this project, the container is provided by the OED. One is the OED web, and the other is the OED database. I will go next slide.
So yeah, in order to access the IBM Z mainframes, we had to go through a VM because obviously we don't have access to those in person, as cool as that would be. This is what it looks like whenever we would go on and try and develop on there. You can go to the next slide. The website view. Okay, so this is actually what happens when we go to the OED website that we were able to port. Only one person can use it at a time because it's the developer version. It's default, just very, very basic OED, but we managed to move it from one architecture to the other. You can try it out by copying their link and putting it in the browser of your choice.
Okay, sorry to interrupt. So I'll actually test it, and I actually see one people coming. I think you guys can see my putty, and I I thought it could be only used by one person per time. So I actually opened it, and I'm not sure who the other user is this, but for right now we are just the mainly default one, the mainly default one. We can log in by we can log in by their default uh, email and password, which I can just type down here. The password is just password, and we can log in. Sorry about this. And other groups, other meters that is not provided, or all these graph, we can change it, but we just don't have groups and the meters. Other language, we can change it. And yeah, it's just basically a pretty default setting of the OED website.
But we did port it, which is super exciting.
Yes. You ready for next slide?
Yep.
Okay.
So my specific contributions were mainly made out of rage. I got angry at Linux, I got angry at Red Hat, and I got angry at Docker in that order. The Linux stuff was really about how Red Hat plays with Docker and Docker Compose. Originally, I thought we didn't have the right architecture on the VM to run Docker or Docker Compose, the right architecture size, rather. I thought we had a 32-bit version of Red Hat. We, in fact, did have the right size, but Red Hat just doesn't like Docker because they want you to use their container management system called Podman. So that's why I was angry about Red Hat. I spent a lot of time fighting with Red Hat to try and get Docker and Docker Compose on there. Peter and I both. Especially because they have a paywall that blocks all of their documentation. Not very open source friendly. So I ended up writing a whole bunch of documentation on how to get Docker and Docker Compose onto all of the different versions of Linux because I was furious that this shouldn't be easier for our open source developers. The last thing I got angry about was Docker, but that was actually quelled pretty quickly. It's a very straightforward, wonderful technology. I did think I needed to learn JavaScript for a while because the web container that we needed to port to a different architecture was written in JavaScript, but we didn't have to change that in the build file. So that was how we were able to port things. Also, shout out to Hunter, our coordinator in RCOS, for having a Docker workshop. It was really helpful to me in my development on this project.
Okay, so next slide is for me. For this project, at the beginning part, for me is the confuse on the Docker and Docker Compose. The Red Hat actually has a Docker, but it's a pretty old version, and so the Red Hat people did not upgrade their Docker and Docker Compose on their Linux, so we need to upgrade it by ourselves. For the so I mean, if we just strictly upgrade on the Red Hat is like kind of hard. So I just find my own ways to upgrade it. I mean, not upgrade, but just to download a newer version of Docker and the Docker Compose. And the Docker Compose download is by the Python 3, and which the bottom left images is what I wrote down for how to download Docker and Docker Compose, a newer version on Red Hat 7.9. And for the OED project, the biggest problem for our port is the web. Since their database is using PostgreSQL, and that seems like support most of the operating system, but the Node.js is different, which the S390X node has its own version, which is the bottom right images. So we need to make like these changes to make it can run on the S390X mainframes.
In the future, we have to test our builds on a whole bunch of different things, other OSs, proper Intel Linux, Mac OS, Windows, and also with data from OED, and also actual production versions. In our web containers, you can say whether or not you're doing this for development or if you're trying to deploy for production. So we hope to actually be able to mark yes for production there.
Yeah, and for me, right now I'm testing on the Windows. Like what I said, the PostgreSQL database is run perfectly fine. The problem for me right now is still about the Node.js. The Node.js does not run well on the Windows. Next slide.
Thank you, especially, well, to everybody who stayed to listen, and also to all of our IBM project managers and advisors, especially Cindy Lee, who met with us every week and helped us out. It's been a great time.
Thank you, Cindy, and thanks for all the people, and thanks for the IBM people too.
Yeah, I'll throw that in as well.
And question time.
So good. Let's see. I'm just looking through the chat. So one of the things that I'm kind of I hate to say happy about on the problems you had is that you guys persevered. These projects, these port projects always sound like they should be easy, and they rarely are. Even with open source technologies, you're finding Docker and Red Hat aren't playing nicely. They don't share toys. So this is, I like the way you guys persevered on this, and I like the fact that you got to something that's actually working. And I also like the fact that you did it on a project that's being actually actively worked on on RCOS this semester as well. Through the OED project. So kudos on that. Here's the $64,000 question. You guys have now walked through and you've gotten something working, and I understand there's still some issues that you're working on. How confident are you that you could do another one?
It probably takes like more times. It is using Docker. Like I believe we are more familiar with Docker than the beginning of the semester. So probably we can do another one, but it just takes it takes time.
Yeah, I don't mean like this semester. I just mean if you had to sit down, would it be easier or harder? Are you confident you could do one?
I feel like after this semester, it would probably be easier, but we also had to learn a whole bunch of new technologies. Xiaoyu and I both didn't really know much about Linux. We both didn't know anything about Docker. So we had to learn all about those. So we wouldn't have to learn that again, but in the future, if we wanted to port other things, we might have to learn a whole bunch of other technologies that neither of us are well acquainted with yet. So it could be easy, but it also could be another long, arduous, anger-fueled process.
That's true.
So I'm going to suggest that easy would not be the I would not count on it being easy. Easier is maybe a better modifier.
Yeah.
So cool. Any other questions for S390X? Because this is what happens, right? I mean, you port things from one architect, as architectures come out, you port things from one architecture to the next. And this is something we'll all have to do at some point. So this is kind of cool that they had the opportunity to do it and in an open source way and kind of breaking new ground on this. Thank you. And thank you for staying and going late. I apologize for that. We got a little bit out of our sweet spot today. But good job. All right, I think that wraps it up. I'm not going to keep anybody any longer. Please post slides, and if you have questions, please continue to ask them. We can move this over to Discord. And thank you for everyone who stuck around. I see some IBM people there still. Thank you for the great work you've done. And we'll see you all for our ultimate class on Friday, which would normally end with a pizza party. So everybody should bring pizza.
Thank you, Cindy.
Thanks, guys. Bye.
Thank you. Yeah, thank you very much, Cindy. Bye.
Thanks.